Now what is that? Okay, a couple of things, guys. This chapter, we all know that the first conductor coming from the transformers into your building, it's called service entrance conductors, right? Especially landed, the ones that enter the building land in a disconnect, service entrance conductor. A couple of things, guys, about the service entrance conductors that we're going to be doing, the terminology that we use with them, how to size them for residential, calculation, which we already did that one. You guys already did that sizing calculation for, especially for residential, the service. Raceways that we can use them. Requirement for grounding and bonding. I'm going to talk about this one. So the most important thing, guys, is the terminology that they use. They use the term service conductor, service drop, service lateral. We're going to talk about what is a service drop, what's the service lateral, what's the service entrance conductors. Very important. And then sizing them, I have no doubt that all of you would be able to size right now because we did that one, sizing. And the bonding and grounding. My concern is with these two terminologies and bonding and grounding. We'll talk, guys, a little bit about bonding and grounding too. The U for grounding, in case concrete, in case grounding system. Talk a little bit about this one. For grounding and bonding in general, guys, I leave this topic to the commercial industrial because there's a lot of aspect of it, but we will touch on that one. Cost of electricity, just a little formula, and I know we touched on this in the past. Equipment in separate, this is important. Equipment in separate building. So what would you do if you're trying to feed building A from building B? That's almost commercial. Building B could be your detached garage. So we're going to see what's the requirement for feeding a building from a building, not a service. So a couple of things, guys, to understand. I have let's go directly into the picture because the picture underground. Here you go. This is directly to the picture. You guys have this picture. It's very important to understand that overhead service conductors, my overhead service conductors, and service drop. This is the conductor. Everybody knows these are the conductors coming from the utility. This part of the conductor all the way coming. This will be your service entrance, overhead service entrance, service drop coming to your utility. Service entrance conductors, you grab it from right here, the point where you tie through the meter, all the way to the panel. This is my service entrance conductors. My service entrance conductors. The reason why this is important because jurisdiction-wise, service entrance conductors, jurisdiction-wise, Brad, all the stuff that we do, all the sizing that we did has nothing to do with the overhead conductors. We have no control over the power coming from the pole all the way to the mast over here that we tie. That's under the jurisdiction of the utilities. We don't size it. We don't care what they do. And one little thing that they do that it's not code. Anybody knows what do they do from here to here that's not code in residential and also commercial sometimes? How many conductors first they give you? 3 conductors. They give you hot and hot and neutral, no ground because you create your own ground. And how about the neutral? Is the neutral fully grounded that they bring to us? It's not. They're neutral. If you look at the cables that come overhead, it's 2 fully insulated conductors and 1 bare conductor, which is that copper, that aluminum conductor, which is the neutral is not grounded. That's anti everything the code says. Neutral has to be fully grounded. The neutral. And so they do 2 things. The utilities do 2 things here. So this is electric utility. Number 1, they give you 2 hots in residential. Plus and neutral. These are insulated. This one is bare. And they also use the neutral as a ground. They use the neutral as a ground. In that cable, the neutral and the ground, they use the neutral as a ground. Okay, this one for the service, guys, we size this one based on 220. Everything that you need to know how to size this conductor, we size it based on 220, yes, sir.
Is that neutral conductor?
Yes.
And So like, sometimes you'll see a cabin with a shed and they got that overhead wire. Can you wire it the same way?
No, if it's a neutral. No, that's a feeder.
Oh, cause it's a feeder.
It's a feeder. Good point. So this is okay because this is not covered by the code. This is territory of the electricity, the electrical company. You can have two hot, insulated, grounded, and neutral bare, no problem, not our territory. Up to here, guys, the green all the way to, this will be my service entrance conductor as you see it right here. And this equipment here will be my service entrance equipment. Who cares? This is how we size them. We size these conductor service entrance conductors based on 220. With you guys did them for me, the calculation, all this good stuff. Very, very important terminology. Any question about the overhead, the service overhead conductors? Service conductor, service drop. So that's the first thing, service drop right in here. If you guys look at the terminology that they do, service drop. Now, if your service is underground, they call them service lateral. And they're changing this in 2011. I don't know if Jeff Koljik told you that. It's changing. So this is the underground, guys, the cable over here, all the way to the utilities, your service. This will be under the jurisdiction, service lateral, underground, all the way to the meter. And from here, you're going to have your equipment all the way to service entrance. Service entrance back to the point of service entrance. Back to the point of service point. Service point would be right inside the meter, right inside the meter.
You don't have to trench to the pole one or to the transformer?
You trench, but they put the cable for you.
They'll drop the line?
They'll drop the line. Well, depends on where your point of connection. Service point, if customers provided underground conductor. You have to decide, a commercial building, your service point might be right at the meter, underground. Or it could be right here. If your service point, if the utility want to have the service point right here, so basically this is your overhead right here, and the whole cable here, from here all the way here, becomes your service entrance conductor.
So it's determined
by the service
utility
utilities. Where they're going to put, see where they put the service. Read guys this one. If the service point was right here, as I say, service point if customer provided underground conductor. You provide underground conductor, your service point becomes here. From here all the way down, that becomes your service entrance conductor. Service entrance conductor. USE cable is there to be used. Any question, guys, about the terminology? So up to here, service drop, service lateral, service entrance conductors. Any question about the terminology? Service drop, service lateral, service entrance conductors, sizing them. You have to decide if you're underground where your point of coupling with the utilities, is it going to be right at the pole? Then you provide the cable. Or if it's a commercial building and the utilities bring their cables to a termination box, they call it termination box. So there will be their cables to a termination box, then we bring our cables to the other side of the termination box and we tie to each other. That's if your service is 400 amps or more. Yes, sir.
If your service is underground,
Yep.
and I'm the customer providing the underground conductors, where am I going to find an electrician that wants to work up on the pole at high voltage running it from there?
You just run it to the pole.
You don't tie it.
You leave like 12 feet at the pole.
Yeah, you don't tie it. You just leave the wires hanging in there, and then the utilities will tie it. It's like putting the. I don't see why not. Throwing your conductors. What you're saying is who's going to go on the pole and put the
Well,
cable?
if I, and I don't know, because I haven't been out there, but most journeymen, are they even qualified to mess with the high voltage?
They're not doing high voltage.
That's
They're
my
not
question.
Yeah.
I'm not making a statement, I'm asking.
You clip them on the service change. You on the service change, you go up and clip them wires, and then you can temporary too. But they'll come and do a permanent connection.
The utility's gonna always deal with the stuff that's gonna go out to the, I mean, it's gonna deal with the high voltage.
Yes.
That's
What
my
you're
point.
saying is
If
the
I'm an
high-
electrician, I'm not gonna tie it into their.
Yeah. When you talk about this 7200 volt.
Not there, but on the other side.
On the other side of the transformer, guys, if the cables are outside, you can tie to the second. That's 220. That's 24120. You can tie to these cables. temporary, where they allow us to go tighter than temporary, and then they come and permanently connect them. But this is really this is a moving object right here. This point could be right here, or it could be depending on where the service is going to be provided. Any question, guys, about the terminology service drop, service lateral? The other thing I want to bring is in residential, my friends, we have to provide two equipment grounding, electrode grounding systems. You have to provide almost two grounding in residential, two grounding electrode systems. I want you guys to look at this grounding electrode system and this grounding electrode system. In residential, we'll go to commercial later. In residential, most likely, almost always, you're going to end up with a rod and what? And tying the water service coming to your building. That will be your grounding electrode conductor. And that's the one that we're going to be sizing based on what? You guys remember that? How we size these? These two? This is going to be table 250.66. That's where your 250.66 cable. So that's the one I want to bring guys about the services. We always create our own neutral bread. We always create our own bonding to the neutral. Our own bonding to the neutral. We create our own grounding electrode system. The same way, guys, if we're here, we're going to go size these conductors based on 250.66. Any question about the service? If I'm to summarize, guys, remember the service drop or service lateral. These are the utility cables, no jurisdiction over them. Service drop, service lateral, if the point of common coupling is here. Then remember the service entrance conductor that we size coming from here, or sometimes it might come from all the way here. Let's just say the service point is right here at the meter, so we're bringing our service to the equipment. That's service conductors. Remember that you have to bond at the service. You have to provide grounding electrode system. We did it, one through the Mother Earth. One of them is through Mother Earth, and the other one ground electrode. And supplemental ground here. So that supplemental ground would be the water. The other thing that guys we do here is we bond the neutral and the ground. We grab literally the neutral conductor and the ground conductor, we tie them together. Anybody knows why we bond them together right here, guys? Why do we bond the neutral right at the service? Why do we bond the neutral and the ground right at the service, right in here? We grab the neutral conductor, and we tie them together. Tie the ground, the neutral, and the grounding system. If you guys remember, if you have a short circuit anywhere in the system, where do you think the short circuit is going to go? One thing to remember, Brooks, is if you have a short circuit wants to go to the source of the current. What's the source of the current in these two systems? Transformer, right? The power source of the current is the transformer. So the box stops with this piece of equipment, guys. If I have a short circuit right in here, if I have a light, and my light is powered from here, and from here, I have my neutral, and I have my hot, and I shorted them. The short circuit current is not going to go to Mother Earth. Its short circuit current is going to go where? To the source. Okay, so the short circuit current is coming out of here. And then at the point, this is say it's shorted to ground. At the point here, if they're not bonded, how is the short circuit current is going to go back to the source? Say if you have a ground fault here, line to ground. Say that was ground, line to ground. How would the current go back to the source unless you bond them? There's a hot, and neutral, hot, neutral, ground. Give me a second here. Hot, neutral, ground. And I have a light. Here's my light. And I have my light is coming from one. Here's my neutral. Here's my hot. Okay?
Chad, you preventing it from going to the box, or you want it to go back?
1 second. And here's my ground. And give me 1 second here. And I have a short circuit. I have a hot. Where's my hot? I have a hot going to the ground. And here's my grounding conductor right in here. See what? I have a short circuit, right? This is a short circuit. Right here. I have my hot, my neutral. So the light is up and running. I have a ground fault right here. So the ground fault current, where would the ground fault current is going to go? From here. It's not going to go through the neutral. It's going to go through the frame all the way back to here. And then what? Then what? It has to go to the source, guys. It has to go, no, yeah, but it has to go to the source ahead of it. How it's going to go to the source? Because right here, here's where my transformer is. My transformer is sitting right in here. Here's my hot. Here's my other hot. Here's my neutral. And now this current is going to go to the neutral. How would this current go to the transformer unless you bond? That's why they bond. So what do they do? Right here, this is the service. This box here is my service. So if you stop right here, guys, how would the current, if you have a ground fault, goes back to the source? Because you said the circuit breaker is in trip. The reason why the circuit breaker trips is because you're bonding, because you're providing low impedance path to ground, low impedance path to the transformer.
Why do you want it to go back to the transformer?
Because that's how the system works. To facilitate.
Why wouldn't you just want it to go into the ground?
It wouldn't know
Oh.
where it's going.
Oh no, that's a
If it's
good.
for lower impedance, wouldn't it be to the ground?
The ground would be low impedance on a copper conductor or an aluminum conductor going between two systems. You have a point. This is grounded at the transformer. This is grounded, and I am grounded right here. Right?
Yeah.
I have my ground, and these are connected through Mother Earth. You're right. So the ground fault, that current can go directly through the Mother Earth. That right, and could trip the circuit breaker, completely right, except it's not fast enough to make it trip, guys, fast. To make it trip fast, instead of depending upon the soil conditions, if the soil is wet or dry or sand. If it's sand, the current will never reach there. It's not going to go through Mother Earth back to the source. So the circuit breaker first might never trip. Second, if they trip, they might not trip fast enough to save you from a short circuit. And we're not talking about 15 amp circuit, guys. What if that load here was a 2000 amp? A huge amount of current. So to facilitate the trip of the circuit breaker, what they do is they grab the hot and the neutral right here, and what do they do to them? They bond them. Now, Brad, that current that could have, would have, should have gone through Mother Earth, which it could, some of it probably would, high impedance to the transformer, now has a very low impedance, very smooth track to go back to where? To back to the source.
You can't damage the transformers.
Right, that's the $64,000 question. How is that not screwing your transformer up if the overload current's going back in there?
How would that screw up your transformer
You have
if the current goes
short
in?
circuit back to the transformer.
Guys, what you're trying to do is you're trying to find a voltage. Here's my current. Here's my voltage. Here's my impedance. When the impedance is very high, the current will be what? The current will, with impedance very low. If the impedance, right? If the impedance is very high, the current will be very low. This means the circuit breaker would never wake up. What you're doing, and that's a situation where if you go through Mother Earth. Now, if you go on bond, then the impedance here of a conductor is what? The impedance of a conductor is very small. Then what would that current be? It would be very high. You're asking about the transformer. Why don't we burn the transformer? Because they're rated to do so. That's why we have them. They're rated to handle this amount of current. When they tell you guys this transformer is rated for 50 kilo, what do you think 50 kilo amp is? This transformer can handle up to 50 kilo amp. These are rated transformers. So if you go higher than that, which you will never be, because the transformer will cap you. The transformer will cap you.
Don't they, I don't know, I was told that if like a tree or something falls on the power line, they do 3 big bursts of electricity and burn it up. Transformers do.
Utilities do it differently. Utilities, they allow you, they size their conductors different. They size their fuses to handle exactly what you said. A tree accidentally hit the transmission line. They have reclosers on the transmission system because if they see a short circuit, they open. and they close again. They automatically close them. They close them because what if the tree drops and it falls off the transmission line? They don't want to cut the whole city out of electricity because just a branch hit the transmission line. That's a whole different animal. They keep closing them, and if it's a couple of times, if it keeps tripping, then they isolate the system and they send the crew to maintain it.
But they do that to burn it off, right?
Not to burn it off. They do that to make sure, like, there's a branch next to a transmission line, guys, and hit the transmission line. You shorted now, momentarily shorted, right? If you open, you cut down a whole city out of electricity, right? Instead of they open, wait a few seconds and close again to see is the short circuit still existing or a squirrel climbing in. There is a squirrel climbing on a transmission line, guys. Burn the squirrel is gone now. I don't have a short circuit. Close. Move on. So anyway, but I can't emphasize this one, guys, as we move into the commercial. Bonding is very, very important. Bonding will allow you to send the current, very high amount of current, back to the transformer so you can facilitate the work of the overcome protection device. Facilitate the work of the overcome protection device. Any question, guys?
Lots.
Okay, go ahead.
Well, let's just
I
keep
don't-
going with
I don't
that.
know.
And how does it rectify itself? We've got all these, there's massive influx of amps, right?
Okay.
Into the transformer,
Okay.
please.
Take it
Rectify.
from there.
This amount, okay. Let's see, let's go to a different page though. Give me.
Thanks, Chris. It's just saying if that does happen.
If it does happen, yeah, how does this whole thing flush itself out?
We'll find out what the problem was.
How do you know there's a problem? With the transformers, right? Or,
Give me.
well, I really don't know how to pose the question because I don't have any practical experience.
30 kVA. You guys mind if I have a transformer 30 kVA?
Where's it from?
Here's a transformer 30 kVA. Transformer equal. Spencer, my friend, here's a transformer 30 kVA. Find the full load current of this transformer. My transformer is 30 kVA, right? How do you find the full load current of this transformer? How do you guys find the full load current of a transformer? Divided by the voltage. Is it 240? What would that give you? Do you have a calculator? 80?
125.
How much?
125.
125. Thank you. 125 amp. What this says, Spencer, what this says is this transformer is a valve. The highest amount of current that this transformer can give you is 125 amp under normal condition. Okay, under normal condition. Now that's how the industry rate them based on the kVA and the voltage. Normally, I can't get more than 125 amp out of this transformer. Normally, that's rating number 1. Okay, so this is going to be my rating number 1. Rating number 2, guys, is a short circuit. Short circuit. They rate the transformer based on the short circuit that the transformer can pump into the system. Pump into the system. Okay, the way they do this, which is coming, they take the I, this is I full load, divided by the impedance. So I have my current, here's my current is 125, okay, Spencer? My impedance for this transformer, they measure them in percentages. So this they give it to you right on an implant. If my impedance is 3%, given right on an implant, okay? Given, manufactured, right on an implant. You take the 125 divided by 3%, which is 0.03, right? Brad, what do you get?
4167.
41.
67.
Point
No,
six.
it's 4,167.
4,100. 4,167. I'm just going to make it in, okay, M. Okay. Divide point, is that true? Point, okay, divide by 0.03 or 0.3?
0.03.
0.03. So this means this transformer is capable of 2 things. Pumping this amount of current into your system In the case of a short circuit, if you go short the phase to phase, that's how much current you're expected to see. Then they rate this transformer without burning the transformer. Of course, you have to clear it. So this meaning this transformer is rated to give you 2 amps. Amp number 1 is a full load amp, and in case of a short circuit, guys, because of the impedance of this transformer will not give you higher than this amount of amps. And then you said, why don't this transformer burn? Because by design, by impedance, by cover, by insulation inside the transformer, it would not give you higher than this amps, and it's rated for this amps. They rate the cover, the insulation inside the windings for this amount of short circuit amps and full load amps. This, guys, you can hold this one forever. This one is rated for, I'm going to say cycles. You can't, guys, you can't just allow this current to sit in the transformer forever. For cycles. Forever. Thank you. Oh, the circuit breaker. They have the mechanism in the circuit breaker. They rate a small device that's called circuit breaker. The circuit breaker has when we study the circuit breakers, there are 2 types of circuit breakers. They see this, a circuit breaker will see this huge amount of energy coming in, this huge amount of current going through it. There's if it's an electromagnetic circuit breaker, magnetically it creates a magnetic field because it's so huge, and that magnetic field will pull 2 contacts to open, pull 2 contacts to open. If it's a magnetic circuit breaker, which is most of it. If it's an electronic circuit breaker, they send a signal from the electronic circuit breaker to, it's like a relay, a signal to a coil, energize that coil, and the coil mechanically, physically open these contacts to interrupt the circuit.
That's why they have to go with those sticks,
So,
right? Reset those things.
Okay, I'm not going to go to that side, guys. Any question?
I'm trying, yeah, that's fine.
Yeah, Brad.
Which is that on the supply side for us?
This is
Or
on-
circuit breaker, or is it on from the utility?
The what? The current?
The circuit breaker.
The circuit breaker is right here. Our supply side. Right here. This is my circuit breaker, right at this point. If you go right here and you short these 2 together. If you guys go and you short these 2 together, right? Grab hot A and hot B and completely short them, right?
Yeah.
This is the amount of current that you expected to get out of this transformer. The circuit breaker is rated, should be rated, to handle this amount of current with trivet within cycles. We talked about last night 3 cycles, or how, most of them are within 3 cycles. They'll trivet, and the circuit breaker should be designed cover-wise and insulation-wise to handle this amount of current that's coming out of it. This huge amount of current for a very short amount of time, guys. And all what we're talking about is 3 cycles. All these are rated for 3 cycles. 1, 2, 3 cycles, bam, circuit breaker will open. This guy is rated to handle this amount of pressure for 3 cycles, no problem. Nothing is going to burn. And the circuit breaker is rated to interrupt this amount of current. So if I have 4160 and I rate my circuit breaker at 10K, it's 10K, right? 10K can handle this. 4167. And then that's why your transformer doesn't burn. And that's why your circuit breaker will open, because this guy is rated for this amount of current. Without getting too much into that one, guys, we will be using a short circuit calculation. There are 2 things that you need to know about. Number 1 is the equipment rating. This equipment is rated for 10K. It can handle 10K. They rate them. And the second thing, the available short circuit. The available short circuit, we calculated it. Here's exactly what we calculated, guys. You write to the transformer. Find the full load current of the transformer, divide it by the impedance that's provided by the manufacturer, get you the short circuit current. Now, that's my start point, Spencer. My start point. I know the worst scenario is that's the highest amount of current I can get out of this transformer. So what do I do after that? I size everything based on the highest current, meaning my circuit breakers will be able to handle this amount. My cables will be able to handle this amount. And guess what? This is going to be sitting in a panel. No, this will be my panel. The panel, the bus, the cover in the panel, the cover or the aluminum buses in the panel will be able to handle this 4167.
that how art class is determined? It's from the graduate?
Yes, with a couple of other things. Okay? All right. So that's what I want you guys to go with me, please, to this to NEC 73. Can you guys go to 73, page 73? Page 73, please. 73. Page 73. In page 73, guys, I want you to look at Article 230.2. This is the old book, sorry. Article 230.2, number of services. A couple of things I want you to know about the services. Buildings, Spencer, cannot, the utilities will not give you more than one service. Unless there's exceptions. One service per building. Very important. One service per building. The exception is if you guys is 230.2A. If you have a fire pump, 73, if you have a fire pump, they give you an extra one service for it. If you have an emergency system, no problem. Legally quiet system, no problem. Optional standby system, no problem. Power production and system designed for connection to multiple sources. So, these are more in the commercial industrial guys, but for the most part, you can only ask for one service. Only ask for one service to your building. There's a special occupancy and capacity. If you guys, if you have, if your system is more than 2,000 amp, the utility can, with request, can give you two services. One service 2,000 amp from this side of the building, another service 2,000 amp from the other side of the building. Special occupancies. If you have special building with special occupancies, means you need two voltages. They will give you, I need a 208 service from this side, and I need from this side a 48277. No problem, bring it on. They can give you. So I want you guys to highlight this, very important. The second one I want to do is page 74, please. Page 74. Page 74, guys, is the clearances.
Hey, I got a question. How do we determine, like, is a duplex considered one service entrance, even though it's just split right at the meter?
A service, this is a service here.
Because it's only.
Very good point. This is a service drop is a service. Now from here, this is one service, guys. From here, I can split this one into as many as I can because it's one service, right? One service. Except if you have the first disconnect, if you have 6 or more, you have to provide more than 6. Like in our situation, we have 4, we have 5, so we don't have to have a main. This is a service. What we're talking about is bringing another service from right here to the same building. That's what we're talking about. A whole complete another service. Okay, I want you guys to look at this one in the book, and these are the clearances above ground for different type of situation. If you have your power lines above ground, there are 10 minimum, as you guys know, minimum clearances. You need a 10, and there's a couple, then 12, and so forth. So this is really a nice picture. All this information, guys, is vertical. The clearances of buildings. This is Article 230.9, clearances of buildings. Vertical clearances, building opening and so forth, overhead drop conductors, the minimum size that we can do the vertical clearances. It's actually 230.24B, vertical clearances, page 75. It will tell you that you need 10 feet minimum, no matter what. And then you have 12 if you are over residential property and driveways. It goes up to 12. It goes up to 15, and I'm reading this from 75, page 75, the right bottom. And 315, it goes 15 if the voltage is higher than 300 volt. So Spencer, if your service is higher than 300 volt to ground, like a 600 volt service. That's a 600 volt service. And it goes all the way to 18 if you're going over alleys. If you're going over alleys and so forth, which is condition, this condition D, you're going over alleys, it goes all the way to 18. So these are important. We really don't have a whole lot of control. Most of the time, guys, the only control part of it that we have is we need to maintain, Spencer, right here, that clearances. This clearances, most of the time, is the only the only control that we have. So if we can't maintain this D, we might have to go raise. What do? You raise the mast a little bit up. Okay. I want to bring to your attention, guys, in page 75, please, size rating. Minimum size conductor you can use.
What order? are you
I'm looking at page
in?
75.
Page, what article?
230.31.
230.31, and I also want to look at 230.23 in the second page. Let's look at 230.23 first. The minimum conductor size, guys, that you can use for service, basically copper or aluminum, is number 8. The minimum conductor size that you can use for service, the minimum conductor size is copper or aluminum, 8 or 6. Obviously, 6 is going to be the aluminum. Both of them, overhead or underground, both these guys, the minimum that you can use covers what? Number 8 CU and number 6 AL. Very important. I'm sorry, these are for the service right in here. For the service entrance conductor coming to the building. So they give you the minimum, guys, that you can do. I want you guys to go to page 71 because really important. Page 71. Page 79. Page 79. Page 79.
It's different in our book. What article are you?
Are you guys in the new book? How many of you are in the new book? Are you in the new book?
Oh, you're in the new one?
Yeah.
Are you in the new book?
You just give.
I'm sorry, I'll give you the article. The article is 230.71, maximum number of disconnects. Maximum number of disconnects. Remember how I told you guys you cannot have more than 6 disconnects rolled in one area? That's where you find it. Now, Spencer, what happens if you need another disconnect, more than 6? What happens, guys, if you need another disconnect? I have here's 1 disconnect, 2, 3, 4, 5, 6. All these are grouped together and they're all served by one utility. Here's what we're talking about, Spencer. All of them are grouped together, served from one utility. Now what happens if I need another one? No problem. You can add a 7th one here. But by adding a 7th one, what do you need to do here? You need to add them in. Done. You just have to add them in. Easier said than done in real application if these are different tenants and they want different services. But anyway, if you need, you can add as many as you want here. Up to 6, you don't need them in. You go higher than 6, you put your in. So that's where the 6 disconnect rules rely. I want to bring to your attention, guys, in page 80 about the service, page 80, which is DJ 230.79, rating of service disconnect means. Page 80, upper left, it says one circuit installation. You can have one service for 15 amps, but don't look at this one. Look at the B. 2 circuit installation, you can have 30 amps. I want C is the most important thing. 1 family dwelling. For 1 family dwelling, my friends, you cannot go less than what? 100 amps. How about if I have all other installation? All other installation, 60. All other installation, 60. These are the most important 2 numbers you're going to remember. If you're doing residential, minimum service to residential is what? 100 amp. If I have non-residential, other than residential, your minimum service to a pump on the side of the street, it's going to be a 60 amp service, regardless of the voltage.
Why is it that they make you put a 200 amp disconnect on the house?
200 amp disconnect, they make you put a 200 amp meter.
Yeah.
Future expansion. That has nothing to do with the code. Future expand. What if, because in the future, if you change a 100 amp panel into a 200 amp panel, they don't want you to go change the meter.
Oh, they're saying minimum from the meter to the panels 100.
100 amp panel.
It's 200. What is that?
The meter will be,
Yeah.
the meter will be a 200 amp, but the panel will be 100 amp. Yeah, 200 amp.
Is that what 6 is? Number E.
Another thing is I want to look at any question, guys, about the sizes. So with size is going to be 100 amp residential, 6 for residential, or 60 non-residential. Another thing I want to bring to your attention, guys, service entrance conductors, Mr. View, my friend, service entrance conductors are not, since they're not protected, service entrance conductor, you have to put them right at the point of entering the building. So the minute that you enter the building, guys, every time, the minute that you enter the building, you have to put your service entrance conductors. Meaning, can I bring that service entrance panel here and put it in an inside wall if I can't put it in an outside wall? No. The code says the nearest point of entering the building. Here's my conductors coming in here. They enter the building. Now, Spencer, I have to put my panel right at the point where it enters the building. If I can't, with special permission, I can put it in an inside wall. I think in Wisconsin, Mr. View, don't they have the 8-foot? 8-foot rule? So they don't want you from the point you enter over here to the point where you put your panel or service entrance, you cannot be more than 6 feet. That's Wisconsin. In Minnesota, the nearest point of entry. So you brought your conductors in, now you have to start thinking they have to land in an overcome protection device. A panel with an overcome protection device. Brad?
What's the reasoning behind that?
Very good point. What's the reason behind this, guys? Here's my transformer, back to my transformer. Here's the power coming in, right? Okay, when you guys look at the transformer, these conductors, the conductors coming in, the only protection that they have is on the primary of the transformer. The only protection, overcome protection that they have is on the primary side of a transformer. What does that mean? It means if I have a short circuit right in here or right in here, if I have a short circuit outside, who cares? There's a big fire outside. It's not going to burn the house. Well, if it's in this side, yeah, you're right. Anywhere here, but if he's on the pole. If I have a short circuit right in this pole, do I care really? It's going to burn right in the air and go. But the minute that enters the building, if I have a short circuit right here that doesn't clear fast enough, you created a fire inside the building. If you create a fire inside the building, what do? You burn your building. So the reason behind it is because these conductors are not fully protected amp-wise. But the minute that you come over here, what do you put? The first thing, you put your 100 amp circuit breaker. Now any conductor coming out of this panel is protected with a 20 amp or 30 amp or whatever. But these conductors from here all the way up to here, the only protection that they have is what? The fuse on the primary of the transformer, which is usually most of the time Brooks is going to be oversized. Most of the time it's going to be oversized. That makes sense? Red, no?
Everything you said makes sense, but I don't understand.
Why?
Yeah, I mean, short of, somebody cutting, if it's 8 foot and it's not in a conduit, somehow somebody cuts it, they're gonna fry themselves, but you're gonna do that whether it's in the panel or not.
The argument for NFPA, remember, the NEC code, guys, is written by what? Firefighters.
Okay.
Firefighters, most of the time, are going to fire. This is really written by firefighters. So their intention is, if this by putting this panel right here, guys, if I can minimize the amount of the likelihood that I can create a fire in the house, that would be great. That's the whole idea. Minimum. Would it prevent it? No. Would it minimize it? Yes. Now, if I have a short circuit, if I put it here, the possibility of having a short circuit right in this period could be zero almost. Your likelihood of getting killed in a car accident driving home tonight is probably 1,000,000 times higher than a short circuit right in a feeder coming in, especially if it's in a conduit. Who's going to be drilled right through it? Could it happen? Yes. So that will minimize the likelihood. Yes, sir.
I got a question.
Yeah.
So, right, so if the minimum size, service entrance conductor wire is an 8 or a 6, it's saying 50 amps, if you take the charge, but they're saying that you could have the minimum, you can have it in a house is 100.
But that's not for houses only. There's 60 for
60, but still, it's only rated for 50. You know what I mean? If you have to have a 60 for other purposes, why are they allowing me to drive a wire size like that?
Okay, give me what's the size that we have? Number 6.
It's, number 6 or number 8, which is rated
How much number 6 can give you?
50 amps.
50 amps.
You're looking under
And just
under
cover,
75 degree column, right?
Minimum.
High?
Yeah, number 6. But And then for number 6, then you would go to number, which
No.
number?
The 6 is the aluminum, it's,
How much you
it's
current?
8 copper and 6 aluminum.
8 copper. Let's do the 8. How much current can 8 can carry?
Under the 75-degree count,
60-degree count.
oh, 40.
40 amp. Now, if you look at the, I know it's not going to be used in 100. If you look at the 1 circuit and 2 circuits, would you have the service disconnect means shall have a rating of not less than 30 amps. So what if you have, I'm just trying to defend them guys, I really, that my all enough. What if you have a service 30 amp, you can have this special 2 circuit service 30 amp because of a voltage drop condition. If you have a 30 amp, the minimum conductor that you can use on it is what? Number 8. Even though you could have gotten away with what?
Oh, the minimum
Number 10.
30 on a building?
With in the
Well, right here
2
it says one
circuit
circuit.
installation.
The A and B.
In a 2 circuit installation.
Right.
So my point is, yeah, on this 30 amp special installation, you could have gone with 10. You can't now because the minimum service you can bring is what? Number 8. Number 8. A couple of things, guys, about the disconnect. The disconnect, you have to have 6.5 feet from the height, the top of the disconnect, for the short people so they can, to the top handle, 6.5 feet.
One circuit
Headroom.
installation, not less than 15.
Um,
Two circuit installation.
illumination. You have to have illumination, and in front of the panel, let's just go here. This is my panel.
379.
If this is my panel, guys, I have to have 30 inches here. And headrooms, this is actually the headrooms, 6.5 up to 6.5 feet. All this area, all this space, Spencer, all this space, 6.5 feet and 30 inches of this panel. Just on the voltage, I'm not going to go to the table. That space is dedicated for electricians to do their work. They don't want you to do anything. Headroom, and you have to have a light over here so people can see what they're doing. Ties bonding. I'm going to move guys into bonding. Any question about bonding on the surface or the service entrance equipment? On the service entrance equipment, Brooks, my friend, we have to do 2 things. Number 1, we have to bring a grounding conductor to the Mother Earth, to a rod, and to the pipe. We have to bond them. That's number 1. Number 2, we have to bond them together with a loop. Radius. Now, if you have a separate building, guys, if I have a building A, main building, building A, and building B, and I'm feeding building B from building A, a few things you have to do, Spencer, a few things you have to do. Number 1, you have to have a main. You have to have a main in building B. Main disconnect, must. Main disconnect. Like in our garages, we brought the disconnect, the little disconnect. You have to have a main disconnect. In new installation, you have to bring a grounding conductor. You have to bring all the hots, the neutral, and the ground, all of them together. You have to create another grounding electrode system. Must. Another grounding electrode system. Okay, so I created another grounding electrode system. Remember, this is the existing one. I created in the second building, I created another grounding electrode system. The only thing I want to bring to your attention, guys, do you bond the neutral and the ground at the second building?
Yeah.
No.
No. That's the only difference. There's some exception. We'll talk about exceptions. No installation, no. You bring a feeder, a 3-conductor feeder, guys, 2 hots, neutral, and ground. Land them, the hots on the circuit breaker, the neutral on the neutral bar, the ground on the ground bar. You bring a grounding electrode conductor and create a grounding electrode system like they did here. The only thing you don't do, see these 2 bars? They don't bond them. versus here. They bonded, you have to bond them at the service. Can you guys see where it's bonded here service? At the second building, you don't bond.
What about out there in the water line, would you have to do that? too?
Yes, thank you. If there's a water line inside this building, see, if the water line is coming, then you have to tie to the water line. There is a special condition, guys, special condition only for existing building. Only for existing buildings, special condition. Special condition, they allow you to not to carry the ground and to bond the neutral and the ground here. Very special condition for existing buildings only. There are a couple of, so no ground conductor, you bond the ground and the neutral at the second panel as well as here. And then the restrictions, guys, is they don't want to have any metallic connection between building A and building A, meaning, do you have a copper water pipe going from building A to building B? If you have, then you can do it. Do you have a phone line going from building A to building B? If you have, then you can do that.
What about the main water line coming in?
Which makes it really almost impossible, guys.
Yeah.
Really almost impossible to use this. They don't want you to do it. And the idea behind this one, guys, if I bond here, if I bond them together, then guess what? If I bond it together, then my neutral, if I bond it together, then my neutral is going to be carrying the short circuit. And in the case of a short circuit, if I bond it together, the neutral will be carrying the short circuit, and the ground, if I have a pipe system, here's a pipe system. Just imagine there's a water pipe. This is just water pipe, water, going from this building to this building. And if I went and I tied these two together, right? I tied them together. So guess what's going to go through this water pipe? What's going to be, say I tied them together, as is, I tied them together. And I have 20 amps here, 20 amps here, 25 amps here. So Spencer, if there's a 20 amps coming in, one and the other, what's the difference between them? 5 amps. They have 5 amps. Look what happened if you bond them. The 5 amps, part of the 5 amps, and I'm going to throw these numbers based on nothing. The part of the 5 amps difference, there will be 4 amps going back on the neutral. And what happened to the other amp? Went back on what? 1 amp going back on the water pipe. Now you start heating your water. Literally heating your water. There's a 1 amp going through the copper pipe, because remember, the copper here is bonded here, and also the copper here is bonded to the neutral right here. So this actor is another neutral. That's the main reason why they don't want you to bond on the second building. Because if you bond on both buildings, the neutral and the ground are in parallel, so the neutral current can take any path that they want. They can take the neutral, most of it will go through the neutral, but some of it, and could be substantial amount, guys, going through the ground, going directly through the ground.
So can somebody get electrocuted if they're working on the water pipe?
Absolutely. Now you come over here and you try to work on this water pipe, not knowing that there's a current 1 amp going through it at 120, and you zap somebody. Or it could be the phone line. It could be the phone line, guys. It could be any metallic object in between them. So, long story short, no installation, complete separation between the hot and between the neutral and the ground over here. You have to establish your grounding system here, though, but you don't tie it. Existing installation only, you tie it.
Yes.
Yes.
Did they just change something on that too, on that thing where they all had to be disconnected, or wasn't it something in that book? The new code thing,
You still have to have your disconnect here.
like the ground had to be disconnected or something, I don't know,
I can't remember, honestly. I can't remember. Any question, guys? This is very important. This can apply to a shed that you have, to a garage, or can apply to a 50,000 square foot building that's fed from this building. So moving forward, I don't even like, guys, to mention that you can bond them. Moving forward, you do not bond. No installation. This is off. You still need to establish your grounding system. Any question? Camille, my friend, Jim? No? Mr. Bab? So that's the cost of power, guys. This is a formula we did them in the calculation. You take the watts multiplied by how many hours, cost per kilowatt hour, and how long it goes, and you calculate your value. So if I have a 100 watt lamp and I will run these by 60 hours and multiply them by the rate, cost per kilowatt hour is $0.07, which is 7 cents, and that will get you how much this 100 watt lamp, if you run it for 60 hours, 60 hours, let's just say 6 hours instead of 66 hours, it will cost you. So that's nothing new on that one. And don't forget that this is per kilowatt. Of course, you have to divide it by the 1,000 because it's per kilowatt.
What is that? Do you know what the cost per kilowatt is?
Isn't it 7 in Minnesota? 7 cents, I think, something like that.
They multiply times 0.07.
Yep.
So, so when you do watts times hours used, if you did it, when you do it 24 hours a day, then would you multiply that by?
Yeah, we multiply that by 24. Any question, guys? Can we have 5 minutes break? And I have a couple of other things I want to mention. Hey, bud.
So,
What do you substitute today, Brad?
Yeah. What do you have?
I don't claim to inform you that I have any idea about what you're talking about.
Okay.
As far as funding goes.
Okay.
When you were talking about this maximum number of disconnects, in my fears coming on, my service is coming into my place. Are they talking about 6 services, 5 services? Or are they talking
Shall
about-
consist of not more than 6 switches.
Right, so 4 sets of circuit breakers or a combination.
Yeah.
When my power is coming into the house.
Okay.
Okay. And it's going into my box.
Yes.
That's what they're talking about. I can't
Yes.
have more than 6 of those.
Yes, unless you have a what?
A disconnect.
I mean, yeah. Really, but this is not. You have.
Oh, okay.
Paper?
Um,
This is not really the main. This is right though. What you just said is right. What the main is, the main point is, they use it. Say you have here's the service coming in.
Yep.
And you need to feed, like we did, multiple buildings. And these are all, or multiple tenants in a building. These are one
Right.
building, multiple tenants. 1, 2, 3, 4, 5, 6. Okay?
mhm.
They're all tenants in one building. That's why I brought one service. Now, when you come over here, since there's 6, what do you do here? First thing you do, you provide one. You have to group them. You have to group them though. So right in here, you provide a disconnect. 1, 2, 3, 1, 2, 3, 4.
I understand what you're trying to say. Now, these are the panels that the power's coming into
Yeah,
for our
look,
different.
but look how they come. They come over here, and then here's disconnect.
Disconnect 1, 2, right.
disconnect 3,
Okay.
disconnect 4, disconnect 5, disconnect 6.
Okay.
Now, if you have another tenant right here,
Mhm.
what would you do?
You apparently have to add a disconnect somewhere here.
You can't.
Okay, so
So
how do you do that?
So look, I can't. I have another tenant here that will do the same system. I can't do it with this. I have to go put a main here for the whole building, and then I can, no problem, I can add another one. Unless these are for fire, there's a few exceptions.
This isn't the, so in our building, so that I can get the illustration in my head. Our main panel, which is where
No,
our,
no min.
there's no main.
Just the ones that we did in data center coming. Remember, if you remember, we came here, we brought
Five
nature,
meters.
yeah, 5 meters. Look, there's nothing here, right? We did not do anything. We didn't do anything. 1, 2, 3, 4, 5, and from here we
We
brought.
did disconnect.
That's a 6 disconnect. Now I can add another one. Now if there's a 7, what do you do?
Or you have to add, right? So how do you do that?
You just do two ways. Now how do you modify this?
That's my
How do you
question.
modify it? Yeah. Well, if this is already, you already bought this one for 5, so you can't do, The only thing you're gonna be able to, like, if you're gonna add the tenants here, so you still can add a six, still go
Right,
up to six,
let's just say
okay?
we wanted to add
When you
something.
add a seven, you want to add a seventh one, out of that whole building here, you're gonna add, so you put a seventh over here, no problem, add another section to it, and then you come put a disconnect right in here. Well, you can between the wires coming in, you put a disconnect for the whole building, that will be your main service entrance port. You just go to the conduit that's coming to the building, cut it.
Well, somebody does.
Yeah,
I'm not gonna. do
yeah,
it.
yeah. Cut it. I'm sorry.
Yeah, just get some. Okay.
And you put the disconnect there.
And one other thing, what you were talking about on this bonding thing here,
You get like.
if this is bonded, and I know that you said that, but apparently in some old installations.
Yes.
it
It's
can
an
be
exception.
doing.
It's like something that you cost.
And this is, I don't care if it's PVC or metal, we'll say for the sake of argument that it's metal. Because this is the conduit that all these are running in, so that's metal, but this is a water pipe.
Yep.
And I checked.
If these are bonded,
Yep.
your green wire and your neutral wire are bonded together, so why is there gonna be any current going across this metal and not going through your green neutral wire?
Good point. Where's the other one? Because the current follows,
You can just go right to the very back page.
There you go.
Or,
Now, because if you have,
It's really
if you have
costly.
a certain load
The
here,
only
a
difference
load,
is.
and here's the hot coming here, here's say 20 amp here,
Yep.
and I need a neutral, here's
Yep,
my
and we
neutral,
have that.
and neutral, no problem. And at the same time, the ground, I have a ground conductor, this is ground, and these four, every these are tied together here, okay? Then, here's what the current does, these are like in parallel. So you have a 20 amp going here,
I don't know you.
if these are the same size, same type, that 20 amp right here, it's going through here and split right here.
Yep, so you have
Then
10 and
even-
10.
Absolutely, you have 10 amp here and 10 amp here. They're parallel
Yep, no, I
to
get that.
go back to the source because they're also bonded here.
Yep.
Okay,
Yep.
so then
So
now
it's working as one conductor, they're tied together. So so.
What's wrong with
the-
that?
What's the problem?
oh, what's wrong
How
with
is the
it?
guy touching the water pipe to get zapped?
Oh,
Because if they're using it currently, it must be relatively safe.
oh, okay. Now let's put a water pipe here. There's a water pipe here with couplings and all that stuff. Now
Sure.
remember, the water pipe is all what happened here. It's already bonded here.
Correct.
And you, if it's in the same second building, what do you need to do too? It's already
It's
bonded
bonded
here.
there.
So here's another pair.
Okay.
So now if the impedance, this will be divided now, what is it, 3, there will be 3, if they're all the same impedance, 3,
Okay.
and now 3.
Okay.
The current now is divided between 3 pairs.
So under what circumstances is that allowable? How, I mean, this is,
Only existing buildings, and if you prove to the authority having jurisdiction that there is no metallic in between them. The thing that comes to my mind, if you live on a farm where there's a tiny little shed way at the end of and you're just bringing a tiny little feeder for it,
Right.
no connection, no pipe, nothing, just power to it, no phone line, nothing, that's not a big deal.
Okay.
But a second building, oh man, there's always be some type of recovery.
little lemon.
You got there, Spencer?
Mango, cantaloupe, and
Where'd you get the cantaloupe? Doug? Where's that cantaloupe from? How many thousands of miles away is that cantaloupe from?
I don't know. South America, probably.
Nicaragua. That was on the news. Yeah. It was on the morning show on K-Fan. Creasel's wife, that's what she does for her.
Like she orders bananas.
She works in logistics for some transportation. Why not?
That's banana farm.
I will.
I'm sure that would be solar power. throw them in your base.
Marijuana thing doesn't work out for man and
That's what you, I'm thinking that's what you should do. You should like pull in a bunch of power so like the utilities get like weary and just like. See if they shut you down.
What's banana pie?
See if they shut you down.
I think it'd be better off with pineapple.
Yeah, at the door. Totally legit. Asparagus
Banana
farm.
plants are so big. Hey, you don't have to open the door.
Oh, but asparagus. It's massive. Asparagus.
Which one?
Yeah, exactly.
You
You don't have to
How
open
do
the
you-
door unless
how
they're
do you
gonna
concentrate?
take notice.
Just wads of cash and bagged up asparagus. all
He
in.
told me somebody advised him not to take it.
Take notice.
So he's talking to somebody. I'm like, yeah, I don't know. He just, I said, he was, I saw me this morning and I said,
Hey, when you're on the phone,
oh, it's things well. I said, he advised me and I tried to get you to advise you not to take it. So I didn't know who was he talking to. Yeah, he just told me. He said, they advised me not to take it. So I don't know if it's his dad or somebody else. No, I was never doing it. We'll see what we're having tomorrow. Yelling.
What did you say about that? Something.
you would have to bring.
His voice
Well, you would have
is
to-
scary.
you'd have to bring
hand is worth the opportunity to shoot
like
two.
all.
To shoot two.
Peter, you get shot with a gun?
If you're just running like we did.
No response?
If you're running.
He's only killed a man once. So that.
Shot with a gun?
Yeah.
That's one of my, yeah, it's one.
I remember we went out, my friend had one of the, like, barrel on us, like, just a huge gun, and we sat out on the
Six.
great, like, get into that can and try to shoot.
DJ.